Do this question, CCC 2011 J4. So the question says that a well plan is prepared before drilling, which specifies a sequence of lines representing a geometrical shape of the future well. However, as new information becomes available during drilling, the model can be updated and the well plan modified. Your task is to write a program that verifies the validity of a well plan by verifying that the borehole will not intersect itself. A two-dimensional well plan is used to represent a vertical cross-section of the borehole, and this well plan includes some drilling that has occurred starting at 0 and -1 and moving to -1, -5. You will encode in your program the current well plan shown in the figure below. So we have to plug in and encode all these coordinates into our program. So the input consists of a sequence of drilling command pairs. A drilling command pair begins with one of 4 direction indicators, D for down, U for up, and so on, followed by a positive length. There is an additional drilling command indicated by Q, followed by any integer, which indicates that the program should stop execution. And these are the assumptions. The program should continue to monitor drilling, assuming that the well shown in the figure has already been made. As we can see, this position, -1, -5, is the starting position for your program. After each command, the program must output one line with the coordinates of the new position of the drill and one of the 2 comments, safe if there has been no intersection with a previous position, or danger if there has been an intersection. After detecting and reporting a self-intersection with danger, your program must stop. Do is we're going to set up a list called drilled, which tracks each spot that we have drilled. And in that list, we'll just start inputting each coordinate. So we'll start from the left column to the right column. So -1, -5.
1 minute later.
Inputted all the coordinates into my list drilled, and this just contains all the positions that have already been drilled, and we have to make sure we don't hit these again after each command by checking if that command and that new coordinate is contained in this list. So now we're going to create 2 coordinates, start x and start y. So we know that we start at -1 and -5, x, y respectively. So start x would be -1, start y would be -5. And we're going to also put 2 variables called original x, original y. And these are used to help track movements from the original point. And this will help print the exact spot when the danger is detected. Now let's move on to our inputs. So while true, because we need an infinite loop, we're going to have our command be input and split it off at the space. Okay, so now we're going to split the input, and the first part of the input will be the direction. This is going to tell us if we have to go down, up, left, or right, or quit the program. So name that D, and that would be the first part. And the number of steps in the direction will tell us how many units we have to move into that direction. So line 1. And now we have created our input system. First off, what we need to check is we need to check if D is equal to Q. We're going to have to exit using SIS, and that would need to be imported. Import sys. For those people who don't know what this is, it's just a function that can help exit the code. You can also use sys to collect inputs and a lot more, but I'm just going to use the traditional function because I'm more used to it. Now, directions are going to be split into 4 ways, as you know: up, down, left, right. Left and right are based on the x-axis. Up and down are based on the y-axis. Let's start with left and right. Let's start with, like, say, left. L if D equals left. We're going to have to take our original x and set it to start x, because start x is going to change and we don't want to lose track of our original position before that. For x in range, we're going to do 1 and steps plus 1. And then we're going to add 1 to start x because we're going in the positive direction. Remember, to the right you go positive, to the left you go negative. So we're going to plus equals 1. We're going to check right now if our current coordinate is already drilled. So we're going to check if this is in our list here. If it is, we're going to add our steps remaining, and we're going to print our coordinates string start y and print danger. There should be a space here. Okay, now after that, I'm going to exit out of the program because there's nothing else we should do. But assuming that we have not hit that, we're going to keep going. And we're going to add our coordinates to the drilled coordinates. Okay, now we're going to do that for the left direction. Sorry. And now, as before, we're gonna do this. It's in range 1 steps plus 1. This time, we're gonna subtract 1 because remember, we're going in the other direction, the negative direction. And now we could just copy this. And that would be all for our left direction. Now we're going to do up and down. Up and down is pretty much the same thing, but in order to do it, we're not going to use X, we're going to use Y. Let's start with up. That would be U. We're going to keep track of our original position. Range 1 steps plus 1. start of y is gonna go up by 1 because up is positive and down is negative. We're gonna check if this is drilled. If it is, we're going to add the remaining steps, and then we're going to print our danger signal and exit. For now, we're just going to add this. Okay, same thing for down, but instead of being positive, we're going to go negative. Oops. Start like minus equals 1, and this part is the same. So that's all for our position. Now at the end, after this has all run, I'm going to exit out of our while true loop, and the fact that we have exited without any errors or dangers, we can now assume that our program is safe. So we're going to print string of original. Our command, we're going to print out our current position, and now we know that it's safe since the program has not ended. So plus string start y plus safe. So now we have our program. We can test it, and that works. Here would be our danger program. Yep, and that's all. Now, this is a relatively medium level problem. It's way simpler if you know how to deal with arrays and lists and how to organize and check through them. Personally, I use Python for this project because it's really easy to check if a coordinate is in the list group. In other languages, you might have to create a function to do that, and that would take more time. But yeah, that's it. Thank you, and subscribe.